6. This is going to be the last section of this chapter, and I believe for the honors class is going to be our last chapter of the book. So this will be the very last video that we do. That's pretty exciting, especially for me, so I don't have to do the videos anymore. All right, anyway, it's a surface area and volume of a sphere. Let's talk about surface area first. So we're going to talk about, oops, terrible line. Let's do a straight line here. We're going to talk about the surface area of a sphere. First of all, what is a sphere? Well, that's a good question. I'm glad you asked, since we're doing spheres. Just happen to have a sphere right here with all this stuff marked in here. And let's take a look. So this whole thing is a sphere. Basically, it's a ball. And, you know, a round ball. I guess if it was a ball, it would have to be round. Well, not necessarily. If you had a football, that's not round. That's not a sphere. But anyway, like a basketball, okay, this would be a sphere. It's got a few things in here. Let's talk about this. It's got a radius. Well, let's go to center first. It's got a center of a sphere, just like a circle has a center. And the radius is the line segment that's drawn from the center to any point on the sphere. Or a lot of times we'll say on the outside of the sphere. So the whole thing is called a sphere. So a line segment that goes from the center to the outside of the sphere. If it stops short, it's not the radius. It's got to go all the way to the edge of the sphere. Okay, that makes sense. That's very much like a circle. So a sphere has a radius as well. And it's got a center as well. And it has a diameter as well. That's what that D is. So from here, if it goes through the center, from one point on the sphere through the center to another point on the sphere, if it's a straight line, then that would be the diameter. Okay, and the same thing is true. If you double the radius, you get the diameter. If you take half the diameter, you get the radius. All right, so nothing real big deal. It also has a circumference. It's the distance, okay, around the whole entire sphere. They stick it kind of looks like an oval right here, but remember, this is a three-dimensional figure, so you have to kind of use your imagination a little bit when you draw it two-dimensionally like this. This is actually a circle. It's kind of like if you took a knife and you cut right through the center. If you cut right through the center and you open both parts up, you would look at it and you would see a circle. Like if you took an orange or something, if it was a perfect circle or a perfect sphere, if you cut it right down the center, okay, not chop off a little bit like this or chop off a little bit like this, but if you cut it right down so it goes through the center, you open both pieces up and you look at it and you're going to see a circle. All right? They call that the great circle. When you cut through the center, that's called the great circle, because you could cut through right here. If you cut right through like that and you open it up, you'd see a circle as well, but that wouldn't be the largest circle. This is the largest circle that you could get by cutting the sphere, and they call that the great circle. Let's see what else. They do this as well. Now let's go to a different color. I'm on white, and it's not going to show up there, so let's go red. See that point right here and this point right here on the ends of the diameters? They call these the poles. And that kind of makes sense, because if you talk about the Earth basically is a sphere. And if you cut let's say this is the Earth, and you cut the Earth right through the center this way, you would have a North Pole and you would have a South Pole. So anywhere you have a great circle. So technically on a sphere, if I even cut diagonally like this, then if the diameter went, let's see, if the diameter went through, I can't hit the center, there it is. If the diameter went through right there, then this would be a pole and that would be a pole. So anyway, the ends of the diameters would be considered the poles. Let's see what else we have. You could have a chord as well. All right, any line segment that just connects 2 points on the outside of the sphere would be considered a chord, kind of just like a circle. So watch, if I just went from like here to here, that would be a chord right there, because it connects one point on the sphere to another point on the sphere, and that would be a chord. Let's see what else we have. Diameter, tangent. You can even have a tangent to a sphere as well. Right? So we've had a tangent to a circle, but this would be tangent to a sphere. We're not really going to get into that in this lesson, but you could have a tangent as well. Remember, the tangent hits the sphere just at that one point. All right? Let's see. I think we covered everything. Now, I believe, yep, we're ready to talk about the actual surface area. So what's kind of interesting is this. if I took that great circle right here, so if I cut right through the center, I open it up and I look at that circle, or I look at the object, it's a circle. Well, if I wanted to find the surface area, if I wanted to completely wrap up this sphere, what I could do is I could take 4 of these circles. So if I took 4 of those circles, it would completely wrap up that whole entire sphere. It wouldn't leave any gaps. Now you might have to do some cutting and pasting and all that kind of stuff if you wanted to really try it. But the surface area of the whole sphere is exactly 4 of these circles. And I like to explain it like that because it's 4 of the circles. So remember, we're doing surface area. So what is the area of just one circle? Well, one circle would be pi r squared. And I said that there's 4 circles. Picture it. You take this and you cover, right? You cut it out and you cover the sphere with 4 of those circles, and that's going to completely cover up that sphere. So what's my formula then? It would be 4 of the circles. That's one of the circles, and that would be 4 of the circles. So the surface area of a sphere is 4 pi r squared. If you forget the formula, just remember, how many circles does it take to cover it all up? It takes 4 of them. So it takes 2 to cover up the top half, 2 to cover up the bottom half, and then 4 altogether. So try to remember that. Try to remember, cut it in half. It takes 4 of those circles to wrap up that sphere. And that's kind of easy to remember. Instead of just memorizing numbers, remember, oh yeah, it takes 4 of those circles to wrap up that whole entire sphere. So a circle is pi r squared, there's your 4, and that's the surface area. That's pretty simple. I tell you what, let's do this. I was going to pause it, but I think we can move on. Remember we talked about cutting it in half? Well, here's a circle that we cut in half, so this is half of it. They actually give this a name, and they call this a hemisphere. You've probably heard that before as far as the Earth is concerned. Oops, can't spell. Sphere, hemisphere. There we go. So it's a hemisphere. Hemi means half, okay? So half of a sphere. That's what that is right there. So what if I wanted to find the area of a hemisphere? Well, it would be half of 4 pi r squared. Remember that? Remember I said it takes 2 circles to wrap up the top and 2 circles to wrap up the bottom? So what would that be? It would be 2 pi r squared. So the hemisphere, the surface area of a hemisphere would be 2 of these circles right here. And so it's 2 pi r squared, because one circle is pi r squared, 2 of them would be 2 pi r squared. All right? And that's a hemisphere. So that's not so bad. And I think we are ready now to do an example. So let's just do the example in the book. It's on page 865. And I'll just use this picture right here. They actually have 3 parts to this. They say find the surface area of the hemisphere. And they give you the radius of this hemisphere, which is 2.8. I think you can read that on top of there. So the radius is 2.8. It's pretty simple, okay? Not that hard at all. And I want to find the surface area, but you got to think a little bit though, because remember, you know what I messed up a little bit. The hemisphere would be, that would just be the round part right here, okay? The sphere part of it. But you also, remember, if you cut it in half, you also have the surface of this base. See how they put base right there? You also have to consider the surface area of that base. So you've got 2 pi r squared plus that circle. Okay, you still got to consider the circle. And what is the circle? The circle is pi r squared as well. So that's also a pi r squared. So if you think about it, the surface area of a hemisphere is what? 2 pi r squared plus 1 pi r squared, which would actually be 3 pi r squared. I don't have that memorized. In fact, I don't think I've ever written it like that. I always think, okay, take half of the sphere, which is 2 pi r squared, plus that circle, which is another pi r squared, and then just plug the stuff in. Or you could just plug it into 3 pi r squared. So if the radius was 2.8, you'd go 3 times pi times 2.8, square the 2.8, and then you would get, let's see, 73.9. 73.9. This is surface area. Let's say it's in centimeters. It's 2.8 centimeters. So area is always squared. Remember, volume is cubed, area is squared, and that's how you would find the total surface area of this hemisphere. Almost forgot about the bottom of it. So you got this dome part of it, right, which would be the 2 pi r squared. Then you got this bottom, this base, this blue part right here. That would be pi r squared. You add them up, that's 3 pi r squared. Plug it in, And then there you go. All right, not so bad. Let's take a look at another example. This is part B on page 865. Okay, here's another sphere, and this time they give you a little bit different information. They tell you the circumference, let's see, the circumference of the great circle. Okay, so that's what this is right here. So this circle right here, they tell you the circumference is 5 pi. You want to find the surface area of the sphere. Well, what do we know to be the surface area of the sphere? It's 4 pi r squared. But they give us the circumference. They don't give us the radius. We got to figure out what the radius is. So you have to remember what your formula is for circumference of a circle. Do you remember what that is? It's 2 pi r. So let's figure out what the radius is. The circumference in this case is 5 pi. So that equals 2 pi r. So you got to solve, it's a weird pi. So you solve for r, divide by 2 pi, divide by 2 pi. That cancels. The pi's cancel right here, so it's 5 over 2. Or you could write it, what's 2.5? So you could write 2.5 if you like. I think you guys like the decimals, so we'll write it as 2.5. So now we know the radius, that's the radius right here. Now we can find the surface area, but just by plugging it in. So finding the surface area wasn't hard, it was finding the radius that took a little bit of thought. So we just put the 2.5 in for radius, we square it, and we work all that out, and you get 78.5. 78.5. This is in meters, I think they said. So it's surface area we're finding, so it's meters squared. So 78.5 meters squared. Let's do another. All right, this problem is actually pretty easy if you think about it, because remember what the surface area of a sphere is. It's 4 pi r squared. It's 4 of these circles. But look what they tell you. They actually tell you the area of the great circle, which is 130. So if it takes 4 of those circles to wrap around, then how do we find the surface area of the sphere? We just take 4 times the area of the great circle, which they give you, which is 130, and you just plug that in and you get 520. That's the surface area of the sphere, inches squared. Now, I was looking at the book, the way they did it, and oh my goodness, I don't understand why they did it this way. Because that would be an exact answer right there. What they do is this. They did, I'll tell you what, let's do that in a different color. I'll show you the way that they did it. And I don't like the way they did it. I like this way better. So what they did is they gave the area of the circle, which is pi r squared, and they said that's 130 equals pi r squared, and they solved for r. So you divided by pi, that cancels out. Then you took the square root to get r by itself, so you took the square root of that. And then what they did is they didn't simplify. They, oh my goodness, what's the word? They, oh my goodness, I can't believe I forget the word. I say this all the time. They rounded. Oh my goodness, I'm getting old, sorry. They rounded to the nearest tenth on this one. So they actually came out to, what, 6.4. But that's a rounded answer. I did this problem the same way, but I kept this number in the calculator. It comes out like 8 decimal places. I used the same number that came out in the calculator, and then I did the rest of it, and it came out exactly 520. Their answer is going to come out a little different because they actually rounded this answer, and then they took this and they squared it, which really, it makes the answer not as accurate. So I'm not really a fan of how they did this. But anyway, I'm just going to show you what they did. So they said, okay, the radius is 6.4. Now let's find the surface area of the sphere. So the surface area of the sphere is 4 pi r squared. And now we can take this value for r and put it right there. So it's 4 pi 6.4 squared. See, this is a really rounded answer right here. This doesn't come out like it really should. So they came out to 514.7, and that was their surface area. This is right. It's not wrong. Okay, it's just that they rounded here, and then when you take a rounded answer and you square it, it makes it even more rounded. Okay, if you want to say that, it makes it less accurate. Is probably a better way to say it. So they came out with 514.7. I came out with 520. 520 is actually a more accurate answer if the area of the circle is 130. Okay, I hope that makes sense to you. This was a lot easier because if they tell you the area of the circle, you just multiply it by 4, and then that's what your surface area of the sphere is. This one, you actually solve for r, they rounded it, put it back in, and then put it into your surface area formula for a sphere, and then they got a rounded answer. This is a less accurate answer, I believe. All right, well, that's enough of surface area. What's the second thing we need to do? We need to do the volume of a sphere. So let's take a look at that. Okay, what I've done right here is I found this picture online, of course, and it's a sphere, but look what it's inside. You can kind of see it around here. It's inside a cylinder. And there is definitely a relationship between volume of a cylinder and the volume of a sphere. Let me write this down. The volume of a sphere is equal to 2/3 of the volume of a cylinder. And that's just getting to the edge right there that says cylinder. Okay, so the volume of a sphere, this ball, this blue ball that's inside that cylinder, is actually 2/3 of the volume of the cylinder that it's in. Okay, so we have learned how to find, oops, let's do this. Let's start right there. We've already learned how to find, let's make that a little thicker so I can see it, since it's yellow. We've already learned how to find the volume of a cylinder. Do you remember that? So this would be, I'll tell you what, let's put an R right there. That'd be the radius. Okay, you could put it right in the middle right here, but I'm doing that on purpose. Okay, so you start from here, the center, you go straight out here. That would be a radius of the sphere. You could also think of it and just drop it straight down from here to here. But what I want to do is I want to show you this. Let's do a different color, but besides yellow, let's go green. All right, and I also want to put this, probably getting a little ahead of myself, but we'll do that. Let's make that a little thicker. There we go. All right. So I've got those two lines right there, and that's pretty important. Do you remember what the volume of a cylinder is? The volume of a cylinder, I'll put just SYL for cylinder. Okay, it's the area of the base times the height. So if you look at this cylinder, the area of the base is a circle, so it's pi r squared plus the height. Now we could just put h for height, but this is a sphere inside of the cylinder. So if you think about it, watch. This right here would be the radius, wouldn't it? And then this right here would be the other radius. So really this green one right here is really the diameter. So, or it's 2 radii. So the area of the, let's see, the area of the base of this, remember it's the area of the base times the height. So the area of the base is pi r squared plus, I'm sorry, hold on. It's not a plus. It's the area of the base times the height. And what is the height of this? The height of this, okay, is 2r. You see that? What am I doing? The height is 2r. We could put diameter, but I want things in terms of radius, so we'll put 2r. So the volume of the cylinder, remember, I'm finding just the volume of the cylinder. This is not the sphere, it's 2/3 of the cylinder, okay? So the volume of the cylinder, forget the ball, is pi r squared, because it's the area of the base. Remember this? Area of the base times the height. It's supposed to be a b. The area of the base times the height. So the area of the base is a circle, it's pi r squared times the height. And when you have a sphere inside that cylinder, that would be twice the radius. So that would be 2r. If, I'll tell you what, let's just keep going. But what did I say is the volume of a sphere? Let's get rid of all that. Okay, what about the volume of a sphere? The volume of a sphere is 2/3 the volume of the cylinder. So watch what I'm going to do. I'm going to go 2/3 this thing right here. So it's pi r squared times 2r. Now it seems kind of complicated, but sometimes we're going to simplify this here in a second. But after we simplify it, you could memorize that. Or you could think of it like this. Think of that, if you forget the formula, think of that sphere being inside of a cylinder. If it's inside of a cylinder, then you can find the area of the cylinder. It's the area of the base times the height. The base is a circle, pi r squared. The height is twice the radius, 2r. But remember, the sphere takes up 2/3, doesn't take up the whole thing. See all these gaps in here? Okay, you got all these gaps, but it takes up a lot of it. It takes up 2/3 of the whole entire cylinder. So I take 2/3, and that's the whole cylinder, and we can come out with a nice formula right here. So let's do this. Let's multiply everything on top. So you got a 2, you got a pi, whoops, let's not go 2, let's multiply it out. Let's go 2 times 2. 2 times 2 is 4, right? This 2 times 2 is 4 right there. Then you have a pi. Then you have an r squared times an r. What's r squared times r? That's r cubed. So that's everything on the top. And then on the bottom, the only thing in the denominator is a 3, so we put that over 3. So if you want to memorize this, that's perfectly fine. A lot of people do. But if you forget what the volume of a sphere is, you can visualize it. Think of this in your head. Think of a sphere inside of a cylinder, and I've already talked about that, but that's what you want to visualize. Or you can just memorize this thing right here. To tell you the truth, there's several formulas now that you have to memorize. I would visualize this, and if you can't remember this, you could always come up with the formula. And that's what we did right here. We just came up with the formula for the volume of a sphere. Let's do a quick example and we'll be finished. Okay, here we go. This is kind of like one we did earlier with the surface area. This time they tell you the circumference of the great circle. They don't come right out and tell you the radius. I mean, that wouldn't be hard at all. If they just told you the radius, you just plug it in and into the volume formula. No big deal. But sometimes they ask you to figure out what the radius is. And we did this earlier, just a couple minutes ago. So the circumference, remember, is 2 pi r. Well, they tell you the circumference in terms of pi, and you think, oh no, they give it to you in terms of pi. That makes it tough. It actually makes it a lot easier. So the circumference is 18 pi. That equals 2 pi r, and I'm trying to solve for r. So I divide by 2 pi, come over here, divide by 2 pi. The pi's cancel. 18 divided by 2 is 9, so the radius is 9. So now, once they tell you the radius, the rest is pretty easy. If you have this memorized, that'll be good. So it's 4 pi r cubed over 3. That's your formula for the volume of a sphere. Probably would be a good idea to memorize it. And again, if not, a few seconds ago, we talked about how to figure it out if you forget the formula. Excuse me. So now we just plug and chug, right? So it's 4 pi r, which is 9, and we cube. Now watch, we cube the 9. We don't cube the pi, we don't cube the 4, we only cube the radius. Make sure that you do that. And then you divide it by 3, and then let me look in the book, what is it, 3053, 3053.6. Now this is volume, and if this is in, what do they put it in? They put it in centimeters, so this will be centimeters what? If it's volume, it's cubed, because look, radius cubed, that would be centimeters times centimeters times centimeters, which is centimeters cubed. And that's all there is to it. And that is the last lesson that I'll be teaching in here. How about that? I'm sure you're excited. Okay, good luck with this. And we're gonna, there is a section 12.7, and I'm skipping section 12.7. So this will be the last section of this chapter, and I believe it's the last section of this book that we'll do. So we'll see you next year, I guess. Bye.